Now to start off this second video for section 4.8, I want to do kind of the classic trig example, which is finding heights. So I know you've done this before, but we're just going to kind of use this as a chance to review how we might use trig. So we're going to try to find the heights of some stuff. And we're going to do the classic, you want to find the height of a tree. So here we go. You decide to find the height of a tree. And you look up and you're standing roughly 10 feet away, and the angle of elevation to the top is about 75 degrees. And so then the question is, what is the height of the tree? In this example, we'll assume that your height is negligent, or you're basically measuring from the ground, that angle. So the first thing to do is going to be to draw a sketch. So we have our tree. Sorry, it looks like I started the keyboard somehow. So we're going to have our tree, and then you have someone standing 10 feet away. And see how we made that nice right angle there. And so now we have 75 degrees. So at this point, you get out your calculator and some pencil and paper, and you figure out, well, I need to find the height. I have the 10 foot, so this side is opposite and this side is adjacent to the angle I'm given. So therefore, I could actually use tangent to do this. Tangent of 75 degrees equals my height divided by 10 feet. And so then solving for the height, you end up with tangent of 75. It's about 3.7 times 10. And I end up with approximately 37.3 feet for the height. So that's sort of that classic, how do you find the height of a tree? Now I'm going to modify this problem. We're going to do a couple more problems involving this tree here. So the second part is, still talking about this tree, you see a crow's nest near the top of the tree. And the angle, you real quick get out your measurer of some sort. The angle to the nest, altimeter I think it's called, is about 73.4 degrees. And so your question is, how far is the nest from the top of the tree? So going back to our picture now, we still have our tree. You're still 10 feet away. But now you notice that there's a nest somewhere here. And you realize that the angle to the nest is 73.5. So height of the nest is going to be Well, I should probably set this up. Okay. I was going to start kind of going a bit quicker, but I think I'll take a step back real quick. So tangent of 73.5 degrees will give me the height of the nest, the opposite side of my triangle, over the 10. And so then solving this, we end up with the height of the nest being approximately, I'm going to do the same thing I did before, 73.5 tangent of that times 10. And so I get about 33.8. So the nest is about 33.8 feet off the ground. Now the question is, how far is it from the top? So we're going to take the top, the height of the whole tree, which was 37.3, and we'll subtract 33.8. So I get that this is 3.5 feet. Make sure I did my mental math correct there. 37.3 minus 33.8. And so we get that the nest is about 3.5 feet from the top of the tree. Okay. Now to modify this equation just a little bit further, I want to try to get one more piece of trig into this. Excuse the barking dog. So I want to get one more piece of trig into this, what we've done in the last couple of days. So the next question is going to ask, you get kind of tired from straining your neck. 75 degrees is quite the angle. So what you do is you actually decide, well, I want to get a lower angle here. I don't want to be at 75 degrees. So you move back so that you're now 50 feet from the tree. And so what is the new angle of elevation? So when you see this idea of angle of elevation, that means if you're looking at the horizon, what is this? And so I can actually just complete this picture here. So this is my tree. It hasn't changed height, it's still 37.3, but this distance is now 50. So the question is, what is this angle? Now, in order to get an angle, you could use that the sum is 180 degrees, but you need two angles in order to do that, and we don't have two angles. So we're actually going to have to use some trig here. Now notice this side is the opposite, and this one's the adjacent. So that tells me that I have to use tangent, and I'll call the angle theta. And it'll give me 37.3 over 50. So in order to calculate the angle, I'm going to use tangent inverse of 37.3 over 50. So I'm going to get the calculator out. 37.3 divided by 50 is about 0.746. I'm going to take the tangent inverse of that. And I get that this angle is roughly 36.7 degrees. And so that would answer that question. So once again, this example was really just kind of the classic finding heights examples. I tried to adjust it a little bit, so we had to use some inverse trig. We also had to use some problem solving in this one to figure out how far the nest was from the top. So rather than just a simple height one, we are technically figuring out this height here. And so a little bit extra to do, but still kind of that classic height example.